In this video, we'll be going through the statistical storytelling homework assignment. And happily enough, this one doesn't have any calculations, so we're just going to be talking through the quiz questions. All right. So, question 1, which type of evidence typically offers the most compelling statistical story? Well, for, let's see, statistics, most objective, study design, context for interpretation, graphics, most information. I'm going to go with a mix of them all because really all of them provide unique things. And so putting them all together is how we really get the most comprehensive story possible. So for instance, statistics are great for that objective component, but we need the context through which we interpret those statistics. And frankly, graphics are the primary way that people want to see those values represented as. It's the most intuitive for many people. So a mix of them all is really going to provide the most compelling story. All right, what do we name as the primary cost of using the wrong tool to provide the wrong kind of evidence? The use of the wrong tool can interrupt the flow. Well, that's true and is not good. Claims are not supported. Well, that's actually probably going to be it. Use of the wrong tool violates ethical principles. Section 2 from Gottlieb's theorem. It's a little inside joke there, but yeah, that's not it. And once you've used it, you won't be able to use it again. Well, none of these are really right. This except for this one. So use the wrong tool could interrupt flow, but use of the wrong tool could also improve the flow. The only problem would be that the claims are not supported. So really, we want the right tool for the right kind of evidence so that your claims are supported and that your story is strengthened. All right, which approach from the videos does Dr. Florin recommend taking with statistical storytelling? All right, as part of telling the story of our held beliefs, need to find the data to show why we're right and why others are wrong. Maybe not. Rather than telling the story of our held beliefs, we need to tell the story of the data. Okay. Rather than tell the story of our held beliefs, we need to tell the story of others' held beliefs. Okay. And as part of telling the story of our held beliefs, we need to find the data that show why we're right. So this one of finding data to show why we're right, these are not good. So these are right out. Rather than telling the story of our held beliefs, telling the story of data or of others' held beliefs, well, again, we're not looking for data to support a position. We're looking to find what is the story that our data tells. So this is going to be the correct answer for this one. Looking for what is the story of that data. All right, which of the below best represents the principle of accept uncertainty? So this is part of our ATOM acronym. So for accept uncertainty, let's see, the fact that sometimes we aren't sure which equation to run. Well, we need to be aware of potential for error while also having an appropriate level of confidence in our decisions. Well, yeah, that's probably going to be it. Accept uncertainty using inferential statistics rather than descriptive, which proof that, well, we never prove. So that one's got a couple of things wrong with it. And then need to accept uncertainty because we don't have data on the population. Really can't have any confidence in the statistics. Well, we don't have data on the population, but the whole point of the statistics is to have confidence in them. So I'm going to go with this. Be aware of the potential for error while having an appropriate level of confidence in our decisions. Again, the idea isn't not that we have zero confidence, even though we don't have the data directly. The idea behind using sample statistics to make inference about the population is that we can acknowledge the error, but still have confidence, an appropriate level, 95, 99, 90% confidence in the conclusions and the descriptions and the decisions that we make. All right, the principle of be thoughtful. Be thoughtful. So let's see. Be careful to select the proper confidence interval or confidence level for the study. Careful to select which statistic we run. Well, it's not bad. Deeply considering what the null hypothesis should be. Again, not bad. careful to consider the context of the decisions, interpretations we're making. So as it relates to be thoughtful, it's not that these other things are bad, it's that this is the principle of being thoughtful, as we describe it in that ADAM acronym, is really being careful of the context for the decisions and the interpretations. So we need to take that into account. Similarly, be open. This one's interesting, and I think this was one that several students struggled with. So remember, it's not the idea of be open necessarily colloquially. This is, what is this principle in the recommendations from the Statistical Association represents? So here, inclusive about who we include in our study. Again, that's not a bad thing. That's just not what they mean by be open. Having an open mind about findings. Again, not a bad thing, just not be open. Making sure the whole process is understood by the audience. That's probably going to be it. Let's check the last one. Whole process is documented somewhere. Well, the documentation is good and kind of part of this, but really the goal is that the process is understood. We really need the audience to understand what happened, and the openness as it's represented here. Again, all of these things are good, and all of these things could be described by openness, but really what we're talking about is that the process, broadly speaking, is understood by who we're trying to communicate to and with. So if it's in the fine print but not understood, that's not what we're talking about. What we're talking about is that it is understood. Same thing about having an open mind. Like, this is a good thing, but the principle of being open at this part in the recommendation is relating to the process and making sure that the process is disclosed, not just in the fine print, but in a way that is actually comprehensible. All right, which of the below represents the principle of be modest? Making conclusions in light of limitations of the study. Okay, well, that sounds pretty good. Avoid talking down to your participants when explaining the study to them. Well, that's a good thing, but not what ASA is recommending with M in the ADAM acronym, be modest. Avoid talking down to your audience. Again, a good thing. Avoid arrogance. Some researchers express among peers, always someone with more experience. Again, all these are not bad things, but when we say be modest in the context of the ASA recommendations, this is what they are discussing. That is, they are recommending that conclusions be made and that you're modest in that there's always limitations of studies. So the conclusions should be made in light of those limitations. And we'll talk about this some in the videos, but yeah, making conclusions in light of the limitations. All right, what should we do when we get unexpected findings? It's a good question. Usually means there's an outlier that should be removed from more expected findings. Outlier. This is a sign that there's a flaw in the data, so we need to find where it is. Consider where they come from and why they're unexpected, and then learn from them. And remember that our data are right. Our hypotheses sometimes aren't. So go with what the data say. Well, I mean, all of these have grains of truth in them, but really understanding them and learning from them is what I recommend. And in this course, we say we should do with unexpected findings. So we really need to understand where they came from. What is the details that created that particular case? Why is it unexpected? So understanding that background context and then learning from that to inform the approach. Data are always right. Just go with what the data say is actually, it sounds like it could be a right answer, but it's not at all. Sign of a flaw in data. Again, that sounds like it could be a right answer, but sometimes unexpected findings are not a flaw in the data. They are a new pattern. So really understanding them is the best approach. All right. Well, I guess this is kind of related. What should we do with outliers? Let's see. We have, we should use fancier statistical methods to address them. So this makes the analysis easier to interpret. We should really keep them in no matter what, even if it was a typo. Well, that's definitely not right? If it's a typo, we definitely shouldn't keep it in. As a rule, we should keep them, though we should check to determine if there's an error or if it's a different subgroup first. Okay, and as a rule, we should get rid of them. Don't represent what our data mean. Well, as a rule, we should keep them. So we keep our data, though we should investigate this. And again, this is what our previous question was discussing with the unexpected findings. So as a rule, we should keep them, though we should check into them for sure. All right, what's the role of inferential statistics in statistical storytelling? Well, let's see. So they are synonymous. All statistical storytelling is inferential in nature. To validly make decisions, descriptions about the population from the sample. Yes, that's going to be it, but let's read the rest. We use inferential statistics in place of descriptive statistics. It's a more advanced version of the same thing. No, not really. And inferential statistics is used when we wish to primarily discuss what happened in the sample, not the population. This is the opposite of these words. So we're going to go with option B here. Validly make decisions, descriptions about the population from the sample. This is the definition / purpose of inferential statistics, is trying to talk about the population using information from the sample. All right, how does the concept of practical significance contribute to statistical storytelling? Describes significance, but for the population should be used when making claims about the population. No, that's not practical significance. Indicates the size of the effect, which should be examined after an effect is found to be statistically significant to determine if it's practically clinically relevant. Okay, yeah, this is probably going to be it, but let's read the rest. The description this describes the situation when we are close to but not quite significant. Well, no. I mean, sometimes you can have practical significance and be close to but not quite significant, but that's not every time by any means. In fact, that's often not the case. Describes statistical significant, but for the sample when making claims about the sample. No, that's just silly. So here, size of the effect, and we look at this after we find it to be significant to determine if it's practically clinically relevant. So practical significance, and again, we talk about, well, why is that important? Because it is. It's really, really important. So what's a common usage of descriptive statistics in statistical storytelling? And there's a whole ton of uses of descriptive statistics. There's a whole ton of places where descriptive statistics are used in statistical storytelling. This is a common thing to do. So when is that? Like, what is that situation? All right, so describing the demographics of the sample to provide context for the population they represent. Okay, that sounds promising. Used primarily when we have population data, not particularly useful with sample data. Well, I mean, it is used with population data, but it's still useful with sample data. Describing details of the population that are unrelated to the direct research question. I guess you could use them. Well, no, that's not really related to descriptive statistics. You could use them for that. You could not. And you could use a whole ton of other things for that too. Used to describe quantitative data when inferential statistics aren't available. Well, no, I mean, you can just, again, it's one of those things that could be the case, but is not necessarily. So when do we do this in statistical storytelling? Well, this is when we're trying to provide context for the population they represent. All right. So what is the proper role of graphics in statistical storytelling? Love me some graphics. So what is the role of graphics? To descriptively illustrate findings from the sample that are supported by inferential statistics. All right, that sounds very promising, but we'll put a pin in that and read the rest. Present detailed information regarding group similarities, differences. Illustrate findings from the population that are aided by descriptive statistics. Definitely not. Objectively show key differences found in the sample. No additional support needed. So actually, this is kind of, these two are a bit contrasting, but objectively, well, graphics, sometimes it's tough to be objective with graphics. And then no additional support needed. Well, graphics really should be supported by inferential statistics because, again, there's questions that often come up with graphics. And so if you're illustrating something, you should have the support that the effect that you're illustrating actually exists or the lack of effect. actually does not exist. All right. Question 14. Of the below, which chart plot is a histogram most closely related to? So scatter plot, no, not at all. Density plot, yes, pretty close. Box and whisker pie chart, no. So density plot is going to be our one. Remember, density plot's just the continuous version of a histogram with a curve instead of little bars. What additional thing could we do with the bar chart that we couldn't do with a histogram? So what's one of our limits of the histogram? Heights of the bars could represent counts or percentages. Well, we could do that with both a bar chart and a histogram. Heights of the bars could represent the value of a second continuous variable. Well, that's actually new in a bar chart. So in a histogram, the heights were kind of counts or percentages, but it's of that variable. A bar chart could have that second variable included, because remember, the bar chart we distinguish based on the groupings. So this is probably going to be, but let's read the rest. Could change the width of the bars. Well, we can do that for both. And use color to add multiple groups to the graph. Well, we can do that with both too. Bar chart does that by default. And with a histogram, we would kind of overlay and add a second group onto the histogram. So we can do that with both. This is going to be the main one that we can't do, which is that the heights of the bars represent this second variable. All right, what's an advantage of the box and whisker plot over over bar charts? So with a box and a whisker plot, we could graph multiple continuous variables at the same time. Could add colors to them. Show both central tendency and spread. Yes, this is going to be the one, and then could display data from multiple groups. Nope. So this is going to be the one. We can always do these other things. We can look at multiple continuous. Well, with bar charts, can't really do that with either of them, I guess. But could display data from multiple groups. Can do that with both. Could add colors. Can do that with both. Both show both central tendency and spread. That is a huge benefit of box and whisker plots, and why I quite like them as a main graphical solution, is that they show both where do we think the middle is and some measure of uncertainty or range around it in a way that bar chart, it just kind of has the bar in its default formulation. All right, scatter plots were primarily used when we have more than two variables, ordinal or better. Scatter plots with ordinal are kind of tough. Have two or three continuous variables, yes. Want to distinguish between the effects from multiple variables? Not really. Need to graph data in 3 dimensions. Well, there's a couple of different methods. So this one, 2 or 3 continuous variables, is going to be our scatter plots. All right, what are which of the following are risks of a low-powered study? Finding an effect in the opposite direction off the population effect. I probably should say of the population effect. I apologize, but that is one. Yeah, we could find an effect in the opposite direction, and if the study is very low-powered, that would be not. We could find a statistically significant effect in the opposite direction, or just an effect in general. Erroneously increasing the probability of finding a significant effect. Well, that's not one. We don't increase the probability of a significant effect with a low-powered study. Not finding a significant effect when there actually is an effect in the population. Yes, this is actually the definition of a lack of power. So far from increasing the chance of erroneously finding a significant effect, we actually decrease the chance of finding a significant effect. Having confidence intervals that are too narrow. Let me see. So narrow confidence intervals mean very precise. No. So this is actually the opposite. Our confidence intervals are going to be not too narrow or too wide. Our confidence intervals will be wider with a low-powered study, and that'll be appropriately wider. All right, the concept of external validity. So the concept of external validity relates to how much we trust our results saying what they think we're saying. Well, that's not external validity, but that is related to something we talked about, and that might be the next question. The degree to which our results have taken into account external factors. Well, that's a fun thing to think about, but is not external validity. How our sample statistics match population parameters. Again, a good thing to think about. This is actually the definition of statistical bias. How well our results apply to individuals, groups outside of our study. So this is external validity. We have this group that we studied. To what degree are these results applicable outside of this context, this immediate context? That is the concept of external validity. All right, question 20, last but not least. Concept of internal validity. Well, we saw it earlier, but we'll go through these options again. Sample statistics match population parameters. That's not it. That's going to be bias. Beyond the scope of this class, you don't have to know that's bias, but in case you're interested. Degree to which results have taken into account internal factors. Well, again, a cool idea, but not what we're talking about. How much we trust the results, say what we think they're saying, and how well our results apply to individuals, groups outside of our study. Well, by test logic, we can remove this one, so we got a 1 in 3 chance. But how much we trust the results, saying what we think they're saying, this is the one that we're talking about. So this is our concept of internal validity. All right, well, that's been our final homework assignment. And so this was the walkthrough of the statistical storytelling homework assignment. I hope you found it helpful. Let's go on and click submit quiz. We'll see how we did. Fingers crossed. Oh, thank goodness. Again, I never know when I do this. So 2020, thank goodness we made it. So yeah, that's been our walkthrough of this quiz. I hope this was helpful. As always, please feel free to reach out, email me if you have any questions. But this is our last homework assignment. Moving forward, we have some writing assignments as they're related to our reading. So this is going to change pace a little bit. For some of you who've struggled with the more technical stuff, there's going to be a couple of questions, related to some of the statistics we're going to talk about, because we will. That's healthcare analytics. We're going to be talking about analytics for the rest of the class. But it will be a lot more focused on writing and practical application now that we've had a lot of these underlying introductory, foundational, I should say, not introductory concepts that we've talked about. So thanks for hanging in there. I hope for those of you who've enjoyed this, I hope you enjoyed it, this type of assignment. And then for those of you who've been dreading these types of assignments, I hope the rest of class is a little bit more conducive to your learning style. But in either case, as always, reach out if you have any questions, and I'll look forward to seeing you in the next video.